Okay, ladies and gents, this is 8.3, right? We talked yesterday or whatever it was about arithmetic sequences. That's when we add or subtract the same thing. You had a common difference. Here we're talking about geometric. Same concept. You're going to do something to the number before it. There's a rule that goes with this every time. But instead of a common difference, we call this a common ratio, right? They're going to call it a common ratio. In geometric, we think of multiplication. All right, so arithmetic is adding or subtracting the same thing every time. Geometric, it's a common ratio, and you're multiplying. Now, guys, if my sequence goes like 24, then 12, then 6, then 3, then 1.5, what's happening each time? You're dividing by how much? 2. We don't talk in division, though, with common ratios. It's always multiplication. So if you're dividing by a number, you're really multiplying by what? 1/2. You're multiplying by a fraction or a reciprocal. Good. So keep that in mind when you see sequences. If they're going down, it's not division. It's just multiplication by a fraction. All right, so if you look here, all right, some things are super easy to see. If I see this, 2 to 4 to 8 to 16. The first thing you do is when you guys have a sequence, you're going to see if it's geometric or arithmetic. If you're adding or subtracting the same thing every time, it's arithmetic. If you're multiplying the same thing every time, it's geometric. Lots of you can look at this and go, oh, 2 times 2 is 4, times 2 is 8, times 2 is 16. So the common ratio is 2. You're multiplying by 2 every time. All right? Sometimes it's not as apparent. If I go from 12 to 36 to 108, obviously it's getting bigger in a hurry. But it just doesn't jump out at you that you're multiplying by 3 every time. The easiest way to find the common ratio is to take the second term and do what? Divide it by the first. That will give you the common ratio every time. So if you have determined, oh, this is definitely a geometric because I'm not adding or subtracting every time. If you just take the second term and divide it by the first, you'll find the common ratio. If you look here, do you guys notice what happens to the signs here? They change, they flip-flop. When you see that, you should know, ooh, my common ratio is going to be negative. Because when you multiply a negative by a negative, it becomes what? Positive. And then a negative times a positive becomes a negative, okay? So look, right away, you guys might have seen from 1/3 to 1/9 to 1/20. You see some sort of 3, right? 3, 9, 27, 81. But that's not, you're not multiplying by 3 every time. You're multiplying by negative 1/3. So in this case, you could easily just say, okay, 1/9 divided by negative 1/3. Keep, change, flip. 1/9 times what? Negative 3 over 1 becomes negative 1/3. You get your common ratio. Easiest way to do that. Almost foolproof. If I were you, I would do that rather than try and do it in your head, because a lot of you would make that mistake here and say, oh, it's negative 3. It's not negative 3. It's negative 1/3. That makes sense? You guys see that? All right. Moving along. Guess what? There's a formula. Okay? Just how we had our arithmetic formula, you have a geometric formula. It's the same kind of concept. When you have this formula, a sub 1, that just means the first term. Right? This is our first term. R is your common ratio, what's being multiplied every single time. And then it's raised to the n minus 1 power. You got to remember that n minus 1. Everybody with me? You guys okay? All right, so let's go. Let's start do some problems here. Write the first 5 terms of the geometric sequence whose first term is 3 and the common ratio is 2. So this is geometric. They told me it was geometric, so I know I'm going to use this formula right here. So if I write the first few terms, well, I have my common ratio, which is 2. My first term is 3. So it's 3 times 2 to the n minus 1. That's my rule. Anybody have any questions about that? You don't multiply 3 times 2, guys, and get 6. It's 3 times 2 to the n minus 1. So now if you wanted to find the first few terms, a sub 1, a sub 2, a sub 3, a sub 4, ... All right, on your quiz, you guys will have basic questions like this, and this is what I need to see. If all you do is give me just term, you're not getting full credit. I need to see that you understand what to plug in. So I would need to see 3 times 2 to the 1 minus 1, 3 times 2 to the 2 minus 1, 3 times 2 to the 3 minus 1, 3 times 2 to the 4 minus 1. Do I need to see that you said 2 to the 0 power? No, I don't need to see all that. But I at least need to see this step. If you want to go one step further and say 3 to the, 3 times 2 to the 0, 3 times 2 to the first, 3 times 2 to the second, 3 times 2 to the third, that's fine. Now guys, remember, what do I do first? Do I multiply or do I do exponents? Exponents. Please remember that. 2 to the 0 power is 1, and 3 times 1 is 3. 2 to the first power is 2, and 3 times 2 is what? 6. 2 to the second power is 4, and 3 times 4 is what? 12. Good. 2 to the third power is 8, and 8 times 3 is 24. Here are the first 4 terms. If I had to do the first 5, which it says, you go one more. But does anyone have any questions about that? If all you do is tell me 3, 6, 12, 24, and it's a 10-point question, I'll give you 2 points. I need to see that you understand what to put in your calculator. Comprende? Okay, good. Let's look at the next one. Find the 15th term of a geometric sequence whose first term is 20 and whose common ratio is 1.05. Okay, they tell me it's geometric. That means I know I use this formula. I want to find a sub 15. I want to find the 15th term. So in order to find the 15th term, I'm plugging in 15 for what letter? N. Good. So my first term, they told me, is 20 times my common ratio is 1.05. And I'm raising that to the 15 minus 1 power. Questions? All right, if I go through here and simplify this, I have 20 times 1.05 to the what? 14th. What do I do first in my calculator? I do the exponent. So I'm going to say 1.05 to the 14th power. And then I'm going to times it by 20. What'd you get, Carlos? Go ahead.
Well, what I got is a very big decimal.
Right, that's okay. So you can, if you want to, you can go ahead and round it to 2 decimal places, 3 decimal places, whatever. Or you can just say 1.05 to the 14th power, hit enter, then hit times 20. On your quiz, it'll tell you what to round to. Right here, I'm just going to round to the 10th. But the 15th term of this geometric sequence is about 39.6. Just calculator work there. Questions? Anybody? We're okay? All right. Moving a little further. Find the formula for the nth term. That means I need the rule or the formula. What is the 9th term of this sequence? Okay, they're asking you 2 questions here. First of all, you have to write the rule. Secondly, you have to figure out what the 9th term is, right? Is that what they asked for? 9th? Yeah, okay. So they told me it was geometric, yes. That means I know I have a common ratio. That means I know I have to use this formula. Did they tell me what the first term is?
Yeah.
Yeah, what is it?
It's 5.
It's 5, all right? Somebody will argue with me, well, they didn't say it's 5. Yes, they did. When you look here, what's the first term you see? 5. You know it's 5. Now I have to find my common ratio. 5 times what is 15?
3.
Times, what's 15 times 3? So your common ratio is 3, right? If you didn't see that right off the bat, if that did not just jump out at you, remember you can say that your common ratio is the second term divided by the first term, which is 3. Recognize it or figure it out, whatever you guys want to do. So we found R. So now I'm going to write the rule. My rule is A sub n equals, first term is 5 times 3 to the n minus 1. On your quiz, you will have a question that has two parts. The first part, this is my answer. You wrote the rule. The second part is to find which term? The ninth term. So a sub 9, all they're saying is plug in 9 for your n. So 5 times 3 to the 8th power. Again, guys, order of operations. What do I do first? 3 to the 8th power. So I'm just going to, in my calculator, I'm going to hit 3 to the 8th power. I get 6561, and then I'm going to times it by 5. 32,805. That is the ninth term of this sequence. Questions? Is this harder than anybody can handle? Not really. Okay. Now, this next question. This is the first thing that we're going to do. All right. It's one of those like we did before with the arithmetic. Given this term and this term, write the rule. They don't give you the first term. So let's just write down what I have. The fourth term of a geometric sequence is 125. So a sub 4 equals 125. And then it says the 10th term, so a sub 10 is 125 over 64. It's a fraction. Oh, goodness gracious. Which term is further away from 0? The 10th term or the 4th term? Okay, good. Good. All right, so just like we did with arithmetic, all right, I'm going to figure out how many spaces away 4 and 10 is. How many? It's 6 spaces, right? You guys agree with me? So we multiplied before. We multiplied the common difference. The 6 times the common difference, right? So in arithmetic, it would be like 6D, but it's not like that now. It's not like that. What we're doing, because think about this, when we had geometric, are we multiplying our n? Is our n being multiplied or is it being raised to a power? Raised to a power. So geometric is a little different. We're going to still follow that same rule. So the first thing we're going to do, in arithmetic we found D. First thing we're going to do here is find R. So again, you guys told me the space that's furthest away from 0 is 10. So a sub 10 equals, if I was going to write this rule or any rule, I'd say a sub 4, so the term that we're talking about here, times your common ratio. This is where our 6 goes, to the power. So geometric uses exponents, so that's how we find our R.
So how do we write out that formula? Did you say a sub 4 equals r like d?
No. There's no D. D is with arithmetic. Just exactly what I did. They already gave me that. This isn't the formula. I'm just using what they gave me. They gave me the 10th term and the 4th term, right? Mm-hmm. So we're going to substitute those in now. We're going to say, okay, well, the 10th term is 125 over 64. And the 4th term is 125, correct? Mm-hmm. You guys with me? Yep. So then I have r to the 6th power. We're trying to solve for r. So what would be the first thing that we would do to solve for r?
You would divide.
You want to divide by 125? Okay, perfect. So r to the 6th power equals, guys, this is what? How do I rewrite this so I can work this problem out? Keep, change, flip. So this becomes 125 over 64 times what? 1 over 125. Perfect. What happens?
The 125's cancel.
Good. So this becomes 1 over 64, right? You guys with me?
Yeah.
Okay.
Yeah.
Now, I don't want r to the 6th power. I just want r.
So you just did, the root of.
You got to take the 6th root of both sides. So r equals, what number times itself 6 times gives me 1?
2, 1.
1.
Sorry.
What number times itself 6 times gives me 64? 2. So you found your common ratio to be what? 1/2, okay?
Is
Now,
it weird
you-
that I started at the beginning without any work?
Say it again?
Is it weird that I knew that at the beginning without any work?
Not weird. I mean, a lot of you will be able, Vincent, you're kind of like a spatial thinker. I could see that this would be a little easier for you than it would be for others. But you got to show me some sort of work. All right? You got to show me some sort of work. Yes, ma'am.
Could it possibly be negative 1/2?
No. Why are you saying that? Let's go back. Why are you saying that?
Because in most of them they're even numbers. And then the square root of 1/64, wouldn't that be
Plus or minus?
Or negative 1/2?
You were saying plus or minus?
Yeah.
I understand where you're going with that. This example just happens to work out that way, but don't think of it that way when you do these, because if we want it to be negative, we'll make sure that the term numbers would come out to be a negative answer. You know what I mean?
Yeah.
Yeah. Very good thinking, but don't worry about that. Okay, so we found the common ratio, right? Yes or no?
Yeah.
Okay. They're asking us to find what? The 14th term. Okay. Now, we could find the first term, and then we could write the rule and all this stuff, but there's a shortcut to that. And it's going to make your life easier, I promise. Once you find the common ratio here, and I'm going to give you some of these problems to practice on the review, I promise. This is the hardest thing we have to do. All right, we're trying to find the 14th term. Did they give me a term that's close to 14?
Yes.
Yeah, they gave me the 10th. I can use either one. I can use either the 10th or I can use whatever's given. I'm always going to use what's closer. I'm looking for the 14th term. Whoops. I'm going to look here for the 14th term. Which is closer? Again, you can use either one. It doesn't matter. I'll show you. But which is closer, the 10th term or the 4th term? The 10th. All right. I'm going to say I can take the 10th term, right? And I can multiply it by my common ratio, right? How many times would I have to go? How many times would I have to do it to get to the 14th term? So this would be to the 4th power. If I use the 4th term, right? If I said if I'm going to try and find the 14th term, and I said I want to use the 4th term, then what would my exponent be here? There you go. So now we can just fill in. We say, okay, the 10th term, right? The 10th is what I'm using? Yeah. All right, the 10th term I said was 125 over 64 times, what's my common ratio? 1/2, and I'm going to raise that to the 4th power. You'll have one of these on your quiz, and it'll be this exact same type of problem. Same process, all that stuff. I put one on the review. Now this just becomes algebra, guys. I have 125 over 64 times, what is 1/2 to the 4th power?
1 over 16.
Perfect, 1 over 16. Because remember that 4 goes to the numerator and to the denominator. You guys with me?
Mm-hmm.
So the 14th term of this sequence is 125 over, what's 64 times 16? 1024.
4 times.
There's your 14th term. So what we did, just to recap, right? We started off and we said, okay, the first thing I need to find is that common ratio. Got to find what I multiply by every time. It should be a given to you that it's a fraction just from the beginning 2 terms, because if I'm going further out in my sequence, if I start at 125 with the 4th term, and then by the time I get to the 10th term, I'm at this little fraction, my numbers are decreasing. So I'm multiplying by a fraction because they're getting smaller, right? You guys should see that. But you find the common ratio first, and then you just use the information that they give you. Use one of the terms that they give you, figure out how far it is away from what you're looking to get, and plug everything in. All right, just kind of let that wash over you. We're going to practice more tomorrow. I promise, I promise, I promise. Say it again. Okay, shooting along, guys. We're going to talk about two kinds of geometric sequences. Finite. Finite means what? Finite means ends. It's got an end. And we're going to talk about infinite, which is infinite. All right, if we talk about a finite sequence, here is the formula that you're going to use. What is a sub 1? The first term. What is r? The common ratio. And what is n? The term you're looking for, or the total number of terms, whatever that we're talking about in our sum. And I'll show you in a second. That should be on your notes, though. All right, so here, look. It says, find the sum of a finite geometric sequence. I want you to look at these two examples. Well, look at this example. Look at your sigma. Do you see how it has a beginning, n equals 1? Mm-hmm. And what's the end number that we're talking about? 12. All right, now how did we find our arithmetic sum that was finite? What did we do? Anybody remember?
We found each of the...
You start plugging in with what number? What do you start? What number do I start plugging in? 1? And then what number do I end plugging in? 12. And then what do I do to all those numbers? Add them together, okay? When you have a geometric, right, the numbers get real big. A lot of times you have bigger numbers. So there is a formula that'll just make this a little easier for you. Literally, guys, the hardest thing about this is to plug it into your calculator. But if I follow this formula, and it's finite because I have a number up here that says stop here. You'll see in a second that infinite doesn't. What is the first term of this sequence, even though they didn't give me any numbers? No. What's the first term?
1.
What's the first term? 4. Guys, what's the number that's in front? Remember when we write our rule? The number in front is our first term, so 4. What's my common ratio? What's happening each time? The 0.3. Okay, when you do this formula, you keep the first term is going to include everything right here because you don't have the n minus 1. So you just that is going to be what's considered our first term, because to find the first term, if I put in 1 for n, correct? If I put in 1, wouldn't you agree that 4 times 0.3 would give me my first term? Yes. In our other formula, it's n minus 1, which would give me which term? When I plug in 1, what's 1 minus 1? 0. It would give me the 0 term. It doesn't give me the first term. So when you're talking about finite geometric sequences, your first term is this whole thing in front because you don't have the n minus 1, you have just n. All right, so we're going to plug that in, and then I'm going to set this up. I'm going to say 1 minus r, so 1 minus, what is our common ratio, did we just say? 0.3. And what is the ending number that they want me to talk about in my geometric sequence? 12. So I'm going to raise it to the 12th power, divided by what? 1 minus 0.3. The hardest part about this, guys, is plugging it in your calculator. Right? We have a fraction. We also have stuff raised to a power. We also have stuff being subtracted in our numerator and denominator. The easiest way to do this, I'm going to write this out so you guys can see it. Parenthesis, then parenthesis, 4 times 0.3. Close your parenthesis. Let me use different colors. This is if you want to do it all at one time. You can simplify it if you want. Then I have another parenthesis. 1 minus 0.3 to the 12th power. Close that parenthesis. Close the big parenthesis. Then we're going to hit divided by 1 minus 0.3. Now, you can do this differently because you're going to round, right? So you can simplify this numerator. Then you can simplify the denominator. Then you can divide the numerator divided by the denominator and then multiply by the outside. But guys, setting up this formula is not difficult. Your A1 is always going to be the number in front and the common ratio because it's to the n power. If you plug in 1, that would give you the first power. The first term. That's why that's A1. Then it's 1 minus the common ratio, which is what's in parentheses, raised to the whatever power is at the top here. And then divided by 1 minus the common ratio. The formula does not change. When you do this in your calculator, you should get something around 1.71. If you don't, we'll practice tomorrow. I promise.
I got it.
You got it? Okay, good. All right, I just want to talk real quick. If the bell rings, don't go anywhere. Just give me 2 minutes. I want to talk real quick about this last one. All right, sum of an infinite geometric series. Guys, how is this one? Look at the sigma. How is this different? How do you know this is an infinite one, even if they didn't tell you? Do you see the infinity at the top here? All right, so finite geometric has a number at the top that says, hey, stop at this one. Wait, don't go anywhere. Infinite has the infinity sign. Here's the formula for the infinite. All right, this one, our A1, does not have the common ratio included. Not included common ratio. And the reason why, okay, the reason why, guys, when I plug in let's just remember it. Okay? Finite, you use the common ratio when you have A1. Infinite, you do not. So in this case, if I was evaluating letter A, I would use this formula. So I'd have A1, which I'd put in what?
4.
I'd put in 4. And I would divide that by what? 1 minus 0.6. And that would be my infinite. You guys would get something, I did this in my calculator already. 10, I think. For B, what's my first term? 3. What's my common ratio? How do I figure it out if I don't see it right away? I'm going to say second term, which is 0.3, divided by the first term, which is 0.10, right? Yes. And then we throw that in our calculator and get about 3.33. So the biggest thing to take from this, guys, right, you have the formulas. I told you in here, if you're in here, you can have an index card with formulas. In a finite, you include the first term and the common ratio. Infinite, you do not.